welcome. Thank you all for coming. My name is Matt Duftler. I'm a software engineer with Google in New York. Really excited to be here with Tom from Waze, Andy from Netflix. It's close. Second time. Talk with you all about Spinnaker. We've all been working together for a few years, but it's nice to have a good reason to get together in the same place once in a while. So I'm just going to be here for a minute. I'm going to introduce Tom and Andy, and then I'll be back in a while. Told my wife we were doing this talk, and I wanted to come up with a Waze joke to give Tom a hard time, and she tried to talk me out of it, said I should just be nice. And then we were thinking, we can let Tom come up, let him get into it, and then every time he's just about to the interesting part, I'll just loudly interrupt him to warn him of a car up ahead or a mattress on the highway or the cops or something. But I won't. Yeah. So I'll be back in a little bit, talk to you a lot about what Google's doing with Spinnaker, and for now, here's Tom.
Thanks, Matt. Thanks, Matt. In 2008, a small startup called Waze was formed. We hit the ground running with a mission to help our users outsmart traffic together. To achieve that mission, we needed very fast feedback from our users. How did we get it? We shipped software features, and we shipped them fast. We did that using a few developers deploying to a few physical servers. However, we couldn't scale on physical hardware. So then we moved to the cloud. Once we were in the cloud, things really started getting complicated. Till now, developers were able to deploy software to production on their own. But as the amount of users grew, we had to start using autoscaling massively, until we ended up with hundreds of autoscaling groups and thousands of instances. The more we grew, the more severe the problem became, until eventually the entire development team lost this capability to deliver software to production. It simply evaporated. And that was mainly due to lack of tooling. Back then, to deploy one backend service to production, developers needed to create images, deploy them to multiple geographically sharded autoscaling groups, usually in a rolling fashion, and rollbacks were extremely painful. So this job moved to the SRE team, which is in charge of Waze production. But at least we were able to grow. So we started out with a goal of fast feedback from our users. But as we hit a certain scale of Waze users, developers, and microservices, the complexity of software deployment went up dramatically. So things were kind of grinding to a halt. There was this bottleneck, but nobody really realized just how bad it was. Once developers couldn't ship as fast as they wanted to, they started batching features into the same release. And it became riskier to deploy like that to production. Even though they wanted to ship fast, once features were completed, they simply could not. And because of the batching of features and bug fixes, releases became extremely large. And it's nasty to work like this, because by now, you are deploying very large pieces of software that could break the system. And when it breaks, it's not clear which one of the 10 features just released caused the problem. So solving it becomes much harder. From the SRE team perspective, the team is working like crazy to ship software, but it's never enough. So everybody's disappointed, and there's a ton of pressure. And from our users' perspective, features arrive slowly, and the system could definitely be more stable. So we looked for solutions. Lucky for us, Netflix was gracious enough to share both their experience and the software they've built to solve this problem, which is Spinnaker. So what exactly is Spinnaker? Well, it's an open source, multi-cloud, continuous delivery platform for releasing software changes with high velocity and confidence. So for us, Spinnaker is essentially a shortcut to achieving what we want. And what we want is fast, safe, and repeatable software delivery with easy rollbacks. So we deployed Spinnaker throughout all of the development teams at Waze. And this is how reality changed. As a developer, I now have the feedback cycle I need. Because right now, deployments are back to a single-click operation, and it's all self-service. I can ship, I can get feedback, and the core of the matter is that I have complete autonomy. And because I have complete autonomy, I don't need to rely on the SRE team anymore, which are now free to work on system stability and scalability, which is a good thing. So we have, and the best part is that our users get features and bug fixes much quicker. So we have happier users. And because we're shipping smaller amounts of features each time, the risk of service disruption goes down. And when there is a problem, solving it becomes much easier. When you see the immediate feedback of your work and have complete autonomy, it gives you more drive and motivation to go even quicker, take more risks, and transform the service to be even more amazing. So that explains things on a super high level. If we drill down, Spinnaker's power really comes from its abstraction and powerful pipeline engine. It allows us to bridge between multiple technology stacks, in our case, VMs and Kubernetes, and cloud providers. It's a sweet spot between just the amount of abstraction on top of each technology, but it is still able to control each stack precisely. That's a bit contradictory, but Spinnaker somehow manages to pull it off. Once applications are using Spinnaker, everybody in the company has this single pane of glass, which can be used to perform the daily work of deploying software. And the main point is that it feels the same no matter what technology stack you are on, whether you are on VMs, Kubernetes, App Engine, or any cloud provider supported. So life was good for a while. As you well know, when you solve one problem, two new problems are created. And they were created. One of them was managing this crazy amount of pipelines in production. And the other was that we were moving too fast. Now, we wanted to move fast, so why is that a problem? Well, it's a problem because it's risky, and we'll get to that in a moment. So by now, we had over 1,000 deployment pipelines in production. All of them were managed through the Spinnaker UI. And it became a huge pain point for the teams to operate, because each of these pipelines were essentially duplicates of one another with slight changes in between them. So for example, adding a stage to all of these production pipelines is too much of a risk for production. There's actually no one willing to do it. So we started looking for solutions. And the idea was to build a paved road deployment pipeline, something that 80% of the development teams could use and be happy with, while the rest of them could change it and adapt it to their needs, but still use it. What happened in the past was that each team had their own set of pipelines, and when they had a good idea, it remained local to that team. Now, with the paved road pipeline templates, these changes are done centrally. So all of these ideas and best practices are available throughout the entire company. So we started off with a simple paved road pipeline. It has a bake, a smoke test or stage, and deploy to production. Each car represents one specific version of an application. Now, from the animation, you can see that what used to be 1,000 separate pipelines are now all using this paved road pipeline. And this encapsulates the best practices we know of how to deliver software to production. And it has also finally become manageable. Remember that problem of moving too fast? Well, this change essentially raised the speed limit of the company from 60 miles an hour to 600 miles an hour. And when you do that, new risks will appear. Now, we wanted to move extremely fast, but it's risky. So we needed more safeguards. In order to solve this problem, we added a canary stage. We evolved our paved road pipeline. Let's see how it looks. So now she's checking each version and deciding. OK. To do that, we simply duplicated the previous paved road pipeline, add in a canary stage, which Matt will talk about later in depth, and then sent one of the applications to the new paved road pipeline, tested it, and once we were happy, we disabled the old one and sent everybody to the new road. So by now, developers woke up one morning and had an option for a safer deployment pipeline. They could now move from a deploy and revert model to a canary model. And this means that they can catch problems early on when it affects only a slight percentage of the users. Let's say one team didn't want to run all of the stages. Well, they could simply bypass it. They could pick and choose whatever stages they wanted to run. And if another team wanted a person to approve deploying to production, well, they could just inject a new manual judgment stage right before the deployment to production. Working with paved road pipelines means that any enhancements or fixes that we want to make to the pipelines are immediately reflected across the entire organization. And that makes it easy to make decisions and have them automated throughout. There are some important technical aspects to weave in. All of this is done as code, with code reviews sent to teammates before each change to this paved road system. So tracking and rolling back is pretty easy. We have a few of these paved roads at Waze. One is for microservices, and the other is for our data layer, Cassandra. We actually run blue-green deployments when upgrading or resizing our Cassandra fleet. And we use pipeline templates and Spinnaker to manage all of this. For example, if we want to stand up a new multi-cloud Cassandra cluster, all it takes is writing a tiny config file, generating the pipeline templates for them, and running them in Spinnaker. Previously, this would have taken way too much time and was prone to error. And now it's fully automatic. So for us, that's pretty amazing. So that's more or less the end of my story. Well, the Waze story. Today, I believe that a new developer at Waze has complete autonomy and can focus on what matters, mainly thanks to Spinnaker. Waze has recently joined the development effort around Spinnaker, and we're specifically focused on adding some SRE concepts like service-level objectives and error budgets. I believe that once Spinnaker is aware of an error budget for an application, some interesting things can start to happen. For example, when a service is almost out of error budget, the canary system could automatically run longer to gain more confidence in new versions. Or perhaps something that was previously fully automatic now has a manual judgment stage kicking in because of the error budget. As happy as we are to be part of the Spinnaker community, there wouldn't be a Spinnaker community if it weren't for Andy Glover and his excellent team at Netflix for starting this project. We're lucky to have Andy here today with us. Andy?
Hey, man. Thanks a lot. That was awesome. So I got to warn you, my slides aren't half as cool as Tom's. My name's Andy Glover, and I run delivery engineering at Netflix. We are the Spinnaker team, and I do work at Netflix, and I want to say thanks to my good friend Matt, who works at Woogle, for the phenomenal introduction earlier. So again, very happy to be here. So at Netflix, we value speed. Indeed, speed of innovation is our competitive advantage. We firmly believe that if we aren't fast, our competitors certainly will be. What's more, our members, you all, anyone here a Netflix member? A few, thank you. Thank you very much, we love you. And we're firmly convinced that you all demand that we move fast. When's the last time you got upset when you put something in your, when you ordered something from Amazon and it didn't arrive the same day? So if we don't move fast, we're pretty sure that you'll go to our competitors. So whether it's to address a bug, add new features, or even add new content, you name it, if we don't move fast and meet your expectations, we're convinced you'll go elsewhere. We also firmly believe that the faster we learn, the faster we evolve and continue to win moments of truth. Netflix is a global company. Our service is used by more than 130 million people every day, and we're available in almost 200 countries. And to facilitate our growth, we have a global infrastructure. We leverage AWS and operate in multiple regions around the world. Moreover, we also leverage a commercial content delivery network, as well as our own fleet of globally distributed servers for content distribution called Open Connect appliances. So operating at this level of scale requires sophisticated tooling that ultimately makes it easy for development teams to move fast with a high degree of confidence, as you saw with Waze. And so that's why we built a continuous delivery platform, a continuous delivery and infrastructure management platform, which we accordingly named Spinnaker. And the key thing is Spinnaker was built leveraging the myriad lessons learned from multiple systems that enabled continuous delivery at Netflix over the past number of years. And so orchestrating the delivery of software assets via Spinnaker facilitates moving fast at a global scale. It has accelerated our time to market. Spinnaker empowers teams to make rapid changes with confidence and thus enables a focus on building the right product for you all. It has also improved developer productivity and efficiency. So yeah, that's my paved road slide. Thanks, Tom. Appreciate it. So yeah, Spinnaker is a platform that enables all the benefits of continuous delivery, and accordingly, it acts as a paved road for making it painless to take ideas and put them in front of users rapidly. This paved road enables teams at Netflix to focus on their charters and not on the nuances of delivery. So ultimately, Spinnaker makes developers' lives easier. And because it's an extensible platform, Spinnaker provides a means to plug into a greater infrastructure of integrated tools and other platforms, like Chaos Monkey, squeeze testing, which we call Citrus, and automated canary analysis, which Tom alluded to with his awesome slides, and which I believe there's going to be a demo as well. We call it Kayenta. And so developers who use Spinnaker, they get all these tools for free without having to write all the glue code to switch together a complex, or to, stitch together a complex delivery process like people were doing before Spinnaker. At Netflix, there aren't any centralized DevOps teams or release teams. Teams at Netflix own their own destiny, building their own pipelines in Spinnaker and managing their apps in production. They leverage what's available out of the box in Spinnaker, but, and this is key, they're free to build on top of Spinnaker, adding their needs so as to efficiently reap the benefits of continuous delivery. So the needs of various teams at Netflix has resulted in powerful extensions within Spinnaker that enable not only rapid and reliable delivery to AWS. Anyone here heard of AWS? Had to sneak that in. But also to Akamai, which is a content delivery network, and to our own container cloud called Titus. You can think of it a lot like Kubernetes. But the innovations don't stop there. Spinnaker has also been extended to facilitate delivery of firmware updates to that fleet of global servers that I called Open Connect appliances, which are distributed across the world in data centers closest to where you live. So when you actually hit play, the video itself is streamed to you from that box, not from the cloud, so to speak, AWS. Spinnaker enables the safe manipulation of feature flags. That is, you can create a complex delivery pipeline for changing runtime data in production without shooting yourself in the foot. And furthermore, Spinnaker now enables the delivery and management of libraries across Netflix. So you can imagine there are teams at Netflix that potentially don't or do not own a service that facilitates streaming. They ultimately own a library that facilitates streaming. And they, too, now are using Spinnaker to effect delivery of those libraries to other teams and managing those libraries once they're in the infrastructure. As Tom said, Spinnaker is open source with a strong and vibrant community, including Netflix, Google, Waze, but also folks like Target, who's here at this conference, my good friends from Pivotal, Under Armour, Microsoft, and that's just naming a few of the large companies investing in this platform. Everyone is innovating within the platform. So not only does Spinnaker integrate with major cloud vendors, but there are integrations with OpenStack, Pivotal Cloud Foundry, DCOS, and even Oracle Bare Metal Cloud. What's more, the community is building new pipeline stages, command line tools for interacting with and managing Spinnaker, and even new Kayenta metric sources like Stackdriver and Datadog. This will all make more sense once you see the demo of canary analysis. And that's just some of the innovations that this community is building within the Spinnaker ecosystem. And so I think all of us within the community would agree that rapid and reliable global software delivery has never been more easy than it is today. And with that, I will turn it over to my good friend Matt from Google.
Thanks, Andy, and thanks, Tom, for setting the bar so high for animations and slides that none of us will ever measure up. All right, so Tom mentioned earlier that Spinnaker enables his development teams to push changes into production with confidence, and I gather he has some kind of confidence because he's going to allow me to push a change live into the production environment at Waze. So if I could have the demo laptop, please. All right, so we'll kick this off, we'll let it run in the background, and then we'll come back and talk about exactly what's going on. So cross your fingers for the demo gods, we'll let that go. And if I could have the presentation laptop again. The one with the slides. The other one with the slides. Thanks. All right, so it's going to push a change. The idea here is that we'll let it work. It'll take maybe 10 minutes or so. We'll come back and poke around the configuration and the execution of that pipeline. It's a live change against Waze. Any of you planning on skipping out early? Bad time to use Waze to get out of San Francisco, but that's on you. All right, so in the past, Google's disclosed many numbers about our internal source control system, and these are incredible numbers. My data's out of date, but things like over 1 billion files, tens of millions of commits, tens of thousands of software developers all working out of the same giant repository. I want to talk about a different kind of a different set of numbers now. The goal here is not really to leave you with an impression about like Google's internal scale or complexity, but more about just our commitment to the Spinnaker project and the surrounding community. So I'm part of the Spinnaker team. We work full-time on Spinnaker. In the last year or so, we've more than doubled in size. We have 13 full-time software engineers, full-time product manager, a technical program manager, and a dedicated engineering manager. He brought stickers. He's around here somewhere. What we're doing, these are some of the things we work on. We support customers and users. Not all of the users we work with are Google customers. Many are, but not all. We're in the Slack channel all the time, just helping people. It's good for the community, and it's good for us because we find out what people are interested in and what's important to companies, so it lets us focus. We built out a large release workflow for building, testing, and releasing Spinnaker itself. The project is 9, 10, 11, I don't know how many independent microservices. It's a big, complicated project. Before we built this release workflow, folks were pretty much just running it at head. Clone all the repos, figure out how to configure it, fight YAML, run it, ask questions on Slack. We built out a process to do regularly scheduled integration tests and have versioned releases across all these independent services, including change logs, pegging changes to future versions, and so on. The goal there was to really make it easier to install and manage, and we'll talk more about that in a second, but also to give confidence to enterprises that it's a real project, a real product, has a version, you can count on it. We'll release patch releases when important things are discovered, and so on. On the topic of installing and configuring Spinnaker, the idea is that you can install it, you can get it running, and then when you have an issue, in the past, we had to go and say, try this YAML file, make this change, and so on. So we built a tool to make that easier called Halyard. We'll talk more about that in a second, but I think it's a pretty good example of something we built entirely out in the open source that makes everybody's lives working with Spinnaker quite a bit easier. We also work on internal usage of Spinnaker. There's some Google teams pushing changes, an internal Google infrastructure using Spinnaker, and we'll talk more about that in the coming months as well. All right, so the obvious question, well, not who is that, because that's somebody who works at Waze, because I've seen him when I visited. But why such an investment in the Spinnaker project? So there are lots of reasons. The first is that the primitives and operations that Spinnaker defines align really, really well with our internal best practices. Things that folks do on internal proprietary Google systems match up perfectly well with what Spinnaker is bringing to the community. Another good reason for us, convergence, whether it's open source software, state-of-the-art software like Spinnaker, or our various cloud offerings that GCP is offering to customers, the more we can align those things with what we do internally, the better for customers, the better for hiring new folks at Google, and so on. It's an all-around good thing. Tom talked a bit about abstractions. The idea with Spinnaker isn't that it creates perfect abstractions over every underlying cloud platform, but that it creates like a commonality, so you have a consistent experience. It's just consistent enough that you can find your way, and hopefully each development team doesn't have to become an expert on every cloud platform that they're targeting. The operations themselves are abstractions for, and it does help you kind of get out of the weeds in terms of like baking images and pushing new versions of your software out into production, doing rollbacks, managing traffic, running canaries. All of these things are defined as first-class primitives, and they let you think at a slightly higher level rather than like fighting every nuance and detail of the underlying platforms. Lastly, Google's tied at the hip with open source software. We contribute to tons of open source projects. We use open source software ourselves throughout the Google stack, so it's everywhere. Spinnaker's really just one more example of Google being part of the broader open source community. So in terms of Google's involvement with Spinnaker, it started maybe 4 or so years ago, late summer 2014. One person working part-time on the project is a 20% project, and it took off from there. We started off with adding support for GCE, and then Kubernetes and GKE and App Engine and so on. And as each platform becomes available, we've continued to add support. And then we've given a lot of that back to the community by helping other folks, some of whom look like competitors, some are competitors, but we're all kind of working together out in the open and sharing what we all know about adding support for additional platforms. And that's been pretty rewarding. So I wrote, make it easy to install and manage. And I remembered there's going to be a video, and I crossed it out. I wrote easier. It's not easy, but it's hopefully easier. This is Halyard that I was describing a moment ago. It's much better than it was. It's definitely easier. It's not simple. It's a big, complicated thing. That's just all there is to it. The types of organizations that adopt Spinnaker are large organizations, typically maybe serving multiple teams across multiple projects, multiple cloud platforms, with lots of complexity and variability, and that requires a pretty sophisticated platform. Spinnaker itself has all these individual services that can each horizontally scale as they need to, and they all kind of cooperate to produce this platform. So it's not trivial to install or manage. But Halyard lets you do it on VMs, on containers, in an atomic fashion or a distributed fashion, handles no downtime upgrades and flipping every option on and off and everything in between. And I wrote advanced topics. I wasn't sure what to call it, but the idea here is that beyond sort of making sure all the table stakes are there to make enterprises happy, we work on a lot of things that I would describe as like adding in best practices and smarts into the platform. Just as we learn things over time, we try to build more and more of that in so companies can adopt this, encourage their own teams to follow best practices, but also kind of share back what we've learned so not everybody has to create like a canary analysis service from scratch, which is what we're going to talk about next. So this is Kayenta. I think Andy mentioned it. It's an automated canary analysis service. That's a mouthful. It's a recently released Spinnaker service. We partnered with another team at Netflix, part of which is now, I think, part of the Spinnaker team proper at Netflix. DET team? Delivery engineering team at Netflix. So we partnered to take a service that they'd been running for many years inside of Netflix, which was like battle-hardened through quite a bit of adoption there, called ACA, and kind of reimagine it and evolve it to be a bit more open and extensible and support a broader set of use cases. And that's what Kayenta is. And we did it with the team that had been working on that service all along. It was open sourced a few months back. Some of the key things we wanted to accomplish out of the gate were to make sure that it supports all of the cloud platforms that Spinnaker itself supports. So it's not geared towards any one platform in particular. So right out of the gate, the day it was released, it could be used with GCE, with AWS, with Kubernetes, every other supported platform. It doesn't really have an opinion about the underlying platform. In addition, it supports an extensible set of metric services. So we released it with support for Stackdriver, with support for Atlas, which is Netflix's own time series database, support for Prometheus, the Armory folks, I saw some of them bouncing around, added support for Datadog. A community member added support for InfluxDB right after it was released. So it's a growing set of metric services it supports. All the way up through UI integration. It's pretty cool to work with, and we'll see some of that in a moment. Lastly, pluggable canary judges. The initially supported judge is the one that was in use at Netflix, is still in use. I think it's just called the ACA judge, but we can call it the Netflix judge. There are other judges in development. Google has some judges internally that we're working on integrating. But the idea is it's extensible and people can do what makes sense there. You're not stuck to one particular approach. So this is going to be, it's kind of quick, and it's just really a taste of what Kayenta offers. We think it's a very good example of the kinds of things we're doing really to push the envelope in the continuous delivery space. There are webinars and things that we've done that you can find online for more details about Kayenta. All right, so this brings us back to the pipeline. So what that pipeline does, and we'll look at it in a second, it orchestrates a canary release for a particular Waze service when a new image becomes available. The idea with canarying changes is that it really should be used for any kind of change. It can be a binary change, like a new image is available. It can be a config change, an infrastructure change. But the bottom line is you have some change you want to make against something running in production, and you want to do it in a safe way. You want to determine in an automated of a fashion as possible whether it's a safe change or not, and you want to make sure to have a very narrow blast radius. And then over time, as you gain confidence in that release, you roll it out to a broader and broader scope. So this particular one is just a new binary image becoming available. This is the service that it affects. It's a Waze text-to-speech service. It generates real-time audio when you're using Waze for navigation. It's a global service. It's available behind a global load balancer, an HTTPS load balancer. It's requested miles in advance, so hopefully no Waze users were harmed in the making of this demo. But it's not really sensitive to latency because it happens way in advance. What we're doing here is we took the running production image and we changed it. We changed it to artificially introduce some latency into the back end. So the load balancer that's forwarding traffic to all of these individual backends is also reporting to Stackdriver metrics on things like backend latency. And in this case, we artificially increase that latency. So the metrics that are recorded in Stackdriver are going to show a higher number for that particular metric. And then we configured an extremely simple canary analysis that looks at just that one backend latency metric and tries to determine with some automated statistical tests whether there's a significant difference there. And this is the basic path of automated canary analysis. You find the strong indicators of safety for your particular use case or application. You configure the canary analysis to look those things up. You make sure they're being published from your application and your infrastructure. And then you apply, at runtime, these statistical techniques, which we can talk more about. And then a scoring strategy is applied. And it's compared to thresholds that you defined for your use case, your pipelines. And then it's treated as a gate for that deployment. Okay? In this case, it's a trivial example. While it's running against live systems, we gave it, 6 minutes to warm up and 4 minutes of runtime. So we're going to get 4 one-minute data points. It's a very small set of data. It's just for a demonstration. In experimenting with it, we ended up turning up the sensitivity of the judge a bit because the judge would basically say this isn't really enough data to have a lot of confidence. So we said, well, we still want to have an answer. So, all right, if I could have the demo laptop, please. All right, so it should finish in about 10 seconds. We'll look at the configuration of this while we wait. So this is a pretty typical pipeline with a canary release. What we encourage for best practices when you're configuring your own canary is don't provision the new canary resources and compare it to everything else that's already been running in production for some period of time. Provision a new set of resources using what's running in production as the baseline and a sibling using the canary configuration. So it's a very apples-to-apples comparison. Use the same infrastructure, provision them at the same point in time, and the single only delta should be the change you want to canary. In this case, it's a new binary image. So that's why you see here there are a couple of lookups. So find the baseline image, find the canary image. And we're just using tag-based lookups to say what's running in production, what's the new image that's available, what's the change we want to canary. Then we deploy a new baseline and a new canary in parallel. And then we have the canary analysis stage. And the way Spinnaker works, each of these stages completes before the next one. It's quite standard control flow. You can see the control flow joins back together at the canary analysis stage. The only thing worth keeping in mind here is you have these two deploys. These are provisioning. Here we're running on GCE VMs. It works the same on whatever platform, but in this case, these are GCE VMs running in managed instance groups. Those stages won't be considered complete until they're considered healthy based on a number of things, load balancers, machine health, and so on. So the canary analysis is quite straightforward. In this case, it's a real-time analysis, which means we're waiting for metrics to be published, collected. You can do a retrospective analysis as well. We refer to a config and think of that as like a templated query. That's also done through the UI. I don't think we're going to show that now. And then you can see a warm-up period, and you can configure a lifetime, and you can break it down into multiple intervals, and so on. And below that, it says, what's the pair of things I want to compare? And in this case, we're comparing a baseline and a canary server group that were just provisioned. I can make it a little bigger. That were just provisioned upstream. And then there's some additional configuration for the query. So when this thing runs, the canary gods smiled upon us. So this failed, which is what we wanted. Okay, and you can see it says canary score is not above the marginal score threshold. And it does, you can see this little red triangle, it's admonishing us that we probably, if we're going to rely on this for production, want to have more data points than that. We'll see in a moment, but I'm sure we have 3 or 4 data points. So this is, I can back out a little bit. This is what a standard set of execution details look like for a Spinnaker pipeline. In this case, it's that canary stage. But you can see the configuration, which said, what are we comparing? What's the warm-up period? How long does the canary run? And then the individual the statuses of the individual tasks that make up that canary stage. And this is, I think, a pretty decent example of what you would have to do if you wanted to script this by hand. You have to do this provisioning. You have to configure this thing to wait for some period of time. You have to make sure things are healthy. Then you have to run the actual analysis, which means go off, build queries, fetch the metrics, figure out how to compare them. You can probably find off-the-shelf statistical tests, and you could probably make all of that work. But the idea with Spinnaker is to make all of that consumable. I mean, we're trying to kind of let you work with a higher level of primitive, and the canary analysis is the latest example of that. So this completed. If we look at the results, we can drill down. And now this is one metric. It's very simple, so the graph is also quite simple. But you can see on the left the name of that metric. You can see that the classification logic determined it to be high, so the canary was high with respect to the baseline. In this case, the only score we possibly could have gotten is 0 or 100 because we only have the one metric, so you can't use any weighted scoring or anything. And then you can see the two lines across. Hopefully you can see the two lines across the graph. The canary is blue, and the baseline is maybe golden axelrod. I don't know what color that is. But you have the two lines there. And then at the bottom, there's some simple statistical details. And you can see it said it got 3 data points for each. And the nice thing about the way we surface this is that everything's available. So you can actually drill down right from the UI, and you can see the resulting queries that were expanded and executed, in this case, against Stackdriver. But it works the same no matter the underlying system. So you can see the metric, you can see the queries, and you can see the actual data points that were returned from Stackdriver. All right. If I could have the slides laptop again. Don't need the video. All right. So what's next? I think we've given a pretty good example of where we are now, and we wanted to talk about what's coming in the coming months. The Spinnaker community itself is pretty warm and welcoming, and like I said, tons of folks are always in the Slack channel, always willing to help, but the code base itself is still kind of like a tough nut to crack, so we want to figure out how to make it easier for other folks to get involved. We've lately been writing more like developer guides, and we're hosting workshops, and this is the whole community, not just Google. But this is one of the main things we're focused on at the moment. Also to really formalize some of our processes and procedures in terms of how the Spinnaker community operates and like how people can become committers and those kinds of things. The set of cloud platforms is always continuing to grow. There's support for this thing called artifacts, which is the idea of instead of embedding logic deep within Spinnaker to understand like what comes from Jenkins or what comes from a container registry, externalize that information. So an artifact would say, this type of thing from this location with this address and this metadata. So we call that artifacts. But we're making that more consumable and adding support for additional systems. The canary stage that we showed had upstream deployment stages, and then later on those things you provisioned to do the comparison have to be cleaned up. We're adding support directly into the canary stage for doing that orchestration to make it easier to configure a canary release. There's a CLI, which at present lets you programmatically publish and interact with pipelines. We're broadening the set of capabilities of the CLI. There's work underway inside of Netflix for the time being to add support for a SQL backend as an alternative for in-flight workflow representation, provide more durability and some other capabilities. And there are several streams of work underway involving configuration as code, from manifest-oriented deployments to approaches where you declare the desired state and then it's constantly trying to achieve that state on some schedule, and a bunch of other related bits. And just think of it as a spectrum from I do everything with a UI and a wizard and fill in fields, or I check in my manifest somewhere, and then whether it's a source control system or some system that supports buckets, and then Spinnaker tries to achieve that state. All right, best is yet to come. In terms of getting involved, we have a site that has tons of information. There are code labs, tutorials, there's documentation, reference architectures. There's all kinds of information up there. We have the Slack channel where there are people in there 24 hours a day, always willing to answer questions. There's a discourse community forum. There are, I don't know how many GitHub repos, but that's the umbrella repo. That's where to start. That's where most of the issues are tracked, so that's a good starting point. And I don't want to forget, we're having a summit in October in Seattle. Looks like it's going to be huge. Come join us. It's open. It's not just for folks who are already involved in the Spinnaker community. It's for people who want to get involved, whether as developers or users or partners or anything else. So please come join us.